Let's take a moment to look at the configuration for remote access VPN. First off, if people are connecting to the outside of the interface of the ASA and we want to authenticate the ASA to the end user, we're going to need an identity certificate. So your identity certificates come from a couple places. First off, when you boot the device, there's a temporary self-signed certificate that gets generated by default. Why does that matter? Well, even if you accept it, verify it, and store it, when you reboot, it's going to change. That's why it's a temporary certificate. So we can't really do that. If you did want to use a self-signed certificate, you'd have to configure it to be persistent and not keep changing. But ideally, you don't want to do that either. What we should be doing is going to a certificate authority that's going to be trusted by devices that we've never seen before. So that if somebody's out in the field, they lose their laptop, they go to Best Buy, they pick up a brand new machine, they go back to their hotel, they start to provision it. We want to make sure when they connect to the outside of our ASA that they know they're connected to a valid device. So we need to use a certificate from a trusted third party here. As far as our users using certificates, if you want to, you could buy them certificates from a trusted third party as well, or you could have an internal CA server, which we tell the ASA to also trust, but then we must tell our external users to trust. And if you can get your external user to trust this CA server, then we can leverage our own certificates for both servers, users, various devices, appliances throughout the organization. And of course, the advantage here is that we can generate certificates ourselves, so there's not going to be that cost of a few $100s for every device that we want to go ahead and add to our PKI. So that was the identity certificates. Let's take a look at the authentication process itself. If we wanted to be very secure, use digital certificates. If you just want to do something quick and dirty, get it up and running and test it. Simplest way to do that is going to be using what we call the local user database. And that local user database is just static passwords that have been configured in the ASA. It's enough to make sure the VPN works, make sure that we can connect. But if we want it to be scalable, what most organizations do is they tie it into an external AAA server. And the ASA can integrate with Active Directory natively, directly. It can speak AD. Alternatively, on your Active Directory domain controller, you can enable Radius by adding the role called Network Policy Server, or NPS. That gives us the ability to authenticate via Radius as well. Or if you've got a larger organization and you're doing a little bit more sophisticated and intelligent things, you might have the Identity Services Engine as the AAA server that you back up against. So a couple different options there for where we store all of our users. Ideally in a centralized database so that we can leverage it for wired connectivity through our switches, wireless through our wireless LAN controller, and of course remote access, leveraging the ASA and firepower. Cisco AnyConnect users are going to select that connection profile. Remember we had employees and partner? And this is going to help us determine what AAA server we bounce off of on the back end when we're trying to authenticate. When we look at the web VPN group, this is what everybody's going to hit by default, and it uses local authentication by default. Again, very simple. If we wanted to change that, we could do it at the default level, or we could do it at a more individual level if it's appropriate. So when a remote user connects, it's a little bit different from a site-to-site connection. A site-to-site connection is basically a pipe that we've constructed between the two offices that allow them to communicate back and forth natively. While with remote access VPN, it's a little different. For one, only the client side can bring up the connection, and the supplicant or end user would be the client, the ASA would be the server. Server is going to have a static IP address typically, unless you're using dynamic DNS or some type of updating service where you can register and get a name to point at it. But for most stability, we're going to want to have a static IP there. The client side, we have no idea what its IP address is. So the client is the only one that can initiate the tunnel. You have an initiator and you have a responder. Site to site, either side can bring up the tunnel. In the case of remote access, only the client side can. So when the client side brings up this tunnel, they don't have any addressing that the ASA knows about. If you think about a static site-to-site tunnel, we know that some network is reachable on the other side. In this case, when the user connects, they're going to authenticate. And if they authenticate correctly, we're going to push down authorization parameters. A lot of times authentication is abbreviated as auth, and authorization is abbreviated as auth-z, just to make the two different. So in this kind of like authorization parameters, we can push down different details. This is what the user is allowed to do. We can push down a split tunneling policy, IP address, DNS server, a WIN server if you're using that. Like I said, VPN filter, which is effectively an access control list. All these details are basically going to be determined and applied when the user authenticates. So the IP address assignment option could come from a few places. It could be within the connection profile. It could also be through something that kind of looks like a DHCP relay, and that the client needs to get on the network, so the ASA does a DHCP request on behalf of the client, gets that IP address, and then passes it back to the user. Alternatively, you could have a local pool in the group policy. So your group policy is typically built on different groups of users. Think sales, HR, accounting, IT, dev, etc. We can have different pools of addresses for different groups of users. This is neat because for logging and for access control lists, whenever you look at an IP address in the logs, you know, oh, that's a remote accounting user, or oh, that's a remote engineering group, because we use these IP addresses for these types of users. Really pretty nice. Additionally, if you want to make it even more scalable, we could put all of this detail, including IP addresses, directly into the AAA server. So regardless of what ASA they connect to, maybe we've got many offices, all those offices come back to the same AAA server, we could always assign the same IP address to that same user no matter where they go. Again, that could happen as well within the local user database if you were doing that configuration directly on the ASA. So split tunneling is a pretty important concept to understand. I think some of you probably know this coming in, some of you may be hearing it for the first time. So let's talk about what it is. When we establish a tunnel, when I launch AnyConnect, I hit the connect button, I successfully authenticate, I get a little lock and it says you are connected. All right, what's that mean? Well, by default, all of your traffic goes through the VPN tunnel, 100% of it. And if you're trying to get to, let's say, a news website, we'd go from the hotel that we're located at through the VPN, hit the ASA uses its routing table and goes, oh, well, the internet's back out that way. So now your traffic, it came in the outside interface, it goes right back out the outside interface, and this is a TCP request, maybe just a HTTP GET request for a web page. That web page will be returned to the ASA, and the ASA will return it through the tunnel. So the nice thing is this gives us privacy. If I'm off in some other city and I'm teaching people how to do man-in-the-middle attacks and grab other people's traffic, at the same time you're like, well, I hope they're not grabbing my traffic. Fire up my VPN, push everything to the outside IP address of the ASA at my house, and then I can pivot off that to get to the internet. That makes sure that anybody around me that's eavesdropping can't see my connection here. It's all encrypted. So that's pretty neat. Gives me a lot of protection. Anytime I go to security conferences, it's a great idea. Now the downsides, what happens if we've got 5,000 users in the field and they do tend to browse the web? Do I want all that YouTube traffic? Do I want all the cat memes? Do I want all the K-pop all coming through my outside interface of my ASA and then being pushed back down to the user? And I bet some of you are going, absolutely, I want to use maybe a WSA, a web security appliance at headquarters, and I'm going to pass all the traffic through this and sanitize it before it goes back to my users. Oh, great, that's a great idea. Maybe you just want to enforce policies, or you want to do auditing from the firewall. That works as well. But if you say, you know what, I just don't want all that traffic terminating in the outside interface of my firewall, well, we could say enable split tunneling. That says allow some traffic to bypass the tunnel. In other words, if you're going to some news website on the internet, you can go there directly. and the only thing that needs to go through the tunnel is corporate traffic. This increases performance, right? It's less latency, it's less hops, it's less work for your ASA to do to have to decrypt and re-encrypt all these messages that were never really intended for it. So nice. The downside is there's no access control for non-tunnel destinations. And the real concern is, let's say that here's your laptop and you visit some website like, let's say, Reddit. On Reddit, they went to the specifically subreddits that had to do with system administration and network administration. Those are better targets to attack, right? Guys like us are system administrators. We've got access to lots of stuff. So maybe we start pushing web exploits or web attacks through Reddit. It can happen on any website. Well, you visit this third-party website, right? Reddit, they're not trying to be hostile, but other members of Reddit load attack code, and that attack code is being pushed at you. Well, simultaneously, you have a VPN up, and there you are attached to the corporate network. If they're able to penetrate your browser, if they're able to get into your system some way, they can use this as a leaping point to get into that corporate network. Where previously, whenever we went to Reddit, it would have been going through the ASA, which may have been punting traffic through a WSA, which may have sanitized something like this. Maybe we could have prevented the attack, who knows? So the neat thing here is that we can really decide how we want our traffic to flow. Everything through the tunnel or not through the tunnel, it's really going to depend on your corporate security needs. I've seen a lot of companies kind of change their stance on this from time to time. So as far as enabling any type of access control in the ASA, it's pretty straightforward. Access control is going to be limited not to interface ACLs, but what we call VPN filters, which are basically access lists that we can assign to individual groups. So here's a group called Employee Group. In the General tab, if you go to More Options, there's Filter. And if Inherit is selected, it's just going to inherit from the default group policy. But if we deselect Inherit, that allows us to make a change. And then for Filter, what we do here is we reference an ACL from a drop-down list. So to configure Remote Access VPN, the steps are pretty straightforward. Remember, you're going to have local user account. That local user will live inside of a group. So we can use the default group policy or we can create a new one. And basically what we have to allocate is IP addresses. When that user wants to attach to our network, what IP address should we use? It's kind of like DHCP. So when they connect to us, hand them an IP address. What should their split tunneling look like? It's off by default. Maybe we want to turn it on. If we plan to use SSL VPN, let's make sure that it's enabled on an interface. Even if you want to use IKE v1 or IKE v2, go to the interface, make sure it's turned on. We can create a connection profile, and this tells us, this is our pre-login policy, how to authenticate the user. Optionally, configure NAT exemption. Optionally, allow VPN traffic with an access control list. So to create local user accounts on the ASA, pretty straightforward. We go to Configuration, Remote Access, AAA Local Users, and we can add a user. Once a user is added, you can see the VPN group policy right here. So everybody's just going to inherit, but if we want to, we can select that and change it to a more specific group. Here, looking at the group policy, one of the important attributes is address pool. When users from this group connect, they have to have an address. Where do we get it from? In this case, a pool called VPN pool. Additionally, under advanced, we can look at things like split tunneling. Do we want to enable it or disable it? Here's where we can specify our policy, and we can say tunnel everything in this particular list. As far as making sure that SSL or IKE is enabled on the interface, we go to Connection, Remote Access VPN, Client Access, and then the connection profile. In your connection profile, you'll see your interfaces, and you'll see types of access, SSL, IPsec, and whether you want to do TLS, DTLS, whether or not we want to allow IKE v2, whether or not we want to enable client services. When traffic comes in through the VPN, should it bypass our interfaced ACLs? So maybe you've got access lists on different interfaces for traffic that's going to go out of them. Does it apply to VPN traffic? We could say, no, it's trusted. We want to bypass the ACL. Anything else here? Nah, we're good. So looking at connection profiles, here's where we could see the authentication method next. Do we want to use AAA or do we want to use certificates? If we use AAA, what's the server group? Local is your local user database. Alternatively, we can point it to a group of Radius servers that contain valid users. Maybe it points to Active Directory. For client address assignment, do we want to use DHCP servers? Do we want to use a pool? Do we want to bother with IPv6? Again, this is a connection profile. This is talking about authentication, getting some addressing perhaps. After we get past the basics, we jump into this group policy to define the rest. So anyone who authenticates with the enterprise profile is going to be passed to employees group. Remember that we can create exemptions for NATing traffic that's going to go through a VPN. So let's say that I'm going to hand a pool of IP addresses to my users. I define that pool as VPN_pool, and it's just a range of IPs, right? This is a network object. I write an access list that says, hey, firewall, when you see traffic coming from 192.168.1.0 going to the VPN pool, don't NAT it. Also, when you see traffic from the VPN pool coming into 192.168.1.0, don't translate it. Makes everything work much, much better. Might not work at all if we don't have this feature enabled. So again, just for troubleshooting, we do the same regular steps. Did our SSL session establish? No. Verify that SSL is enabled. Make sure that your cipher is supported. Older operating systems, older browsers may not be compatible. Okay, SSL worked. Did the user authenticate? If not, validate the username and password. Validate your AAA configuration. Did tunnel permissions get assigned? No. Check your group policies. Did IP address get assigned? No. Again, look at the IP address assignment method. Did you use DHCP? Did you have a pool? If all of that works correctly, you should have a VPN established. Again, if not, some additional things to check. Maybe our tunnel's up, but traffic isn't flowing like we hoped. Check the split tunneling policy. You can look at your routing table on the client side, or we can verify the split tunneling configuration on the ASA side. Maybe your tunnel's up, but traffic isn't flowing. Is there an ACL applied? If not, is routing correct? Additionally, things to think about. Is our traffic exempted from NAT? And again, just making sure to double check our routing. If routing is pushing flows through the tunnel and our security parameters are configured correctly, the tunnel should be up and everything should be working.